This lesson is on solving equations, quadratic equations, using the method completing the square. The method in completing the square is when you take an equation, a quadratic equation that is in standard form, and you convert it to vertex form. We use this method not only to identify the vertex, but also to find the solutions of the quadratic equation. This method has a tendency, or this lesson has a tendency to be very lengthy. So you'll see as we go that there are times I'll ask you to stop the video and to work out a problem on your own. And then when you're finished, to start the video up again so that you can compare your work with my work and see if you're doing it correctly. To begin with, we need to review what is vertex form. Now, as you recall from previous lessons, standard form is ax squared plus bx plus c is equal to 0. Whenever we have our equation in standard form, we should always have it set to 0 because we use this form to identify our x-intercepts, and the 0 is representing our y of our function. The a in the standard form is going to be the same a that is in your vertex form. And the x of standard form is the same x that's in your vertex form. We do have two new variables in our vertex form, and that is the h and the k. The h is located here in the formula, and the k is here. One important thing to point out with the formula is the operations. We need to have a minus sign and a plus sign. Now the h and the k are representing the actual vertex of the parabola. The h is going to be our x value, and the k will represent our y value. So any numbers that are in that location of the formula will be our x and our y of the vertex of the parabola. Here I have three examples of equations that are in vertex form. I'm going to use this form to not only identify the vertex, but the x-intercepts. The very first thing I need to look at are my h and my k values in my formula. My h is 2 and my k is a -4. The reason I know that h is 2 is because in the formula, the operation should be a minus or a subtraction. And here in the formula, this operation should be a plus sign. So if I have a minus for the 2, that tells me that I have a positive 2. I do have a -4 written down, and because it should be a plus sign, that tells me that the y of my vertex is a -4. Again, the formula is a times x minus h squared. Let me write that again. A times x minus h squared plus k equals 0, with my h and my k being my vertex. So because I have a minus sign next to the 2, that makes my 2 of my vertex a positive. And because I have a minus sign next to the 4, and it should be a plus, that tells me that my y is negative. Very important to watch those operations. Now, in order to find my x-intercepts, I'm going to isolate the squared portion of my equation. I like to call this the quadratic portion. It's not really an official name for that part, but it helps us to understand that's the part that makes this a quadratic equation, is the fact that there's a squared there. So in order to isolate it, I'm going to add 4 to both sides. And when I add 4 to both sides, my -4 and my +4 cancel out. And I'm left with x minus 2 squared. That's my quadratic portion. And that is equal to 4. Now, just like simple equations, in order to get rid of that squared side, or the x minus 2 squared, I'm going to take the square root of both sides. And I'm going to be left with x minus 2 which is equal to a plus or a minus. Do not forget that plus or minus. The only time you have one answer with your quadratic equations when you square it is if you have a 0 in your radical. And I don't have a 0, I have a 4. So it's going to be a plus or minus 2 because the square root of 4 is 2. I then will take both of these equations and I'm going to break them up into, I'm going to take this equation and break it up into two parts or two pieces. One for the plus 2 and one for the minus 2. So I have x minus 2 is equal to my positive 2 plus 2. I don't need to write that plus, but I'll write it just so you understand where it's coming from. And my other equation is x minus 2, which is equal to my negative 2. I'm going to add 2 to both sides, and I will be left with x is equal to positive 2. Here I will add 2 to both sides, change my colors so I match. I'm going to add 2 to both sides, and I'm going to have negative 2 plus positive 2 is 0. So x is equal to 0. Now if I want to check my equation, I can do that by plugging in my x's. So I can start off with, I'm going to write over here even though it's under other problems just so you can see. I can replace my positive 2. So here was my original equation, x minus 2 squared minus 4 is equal to 0. So if I plug in a positive 2, 2 you probably caught that I had made a mistake, and I saw that as soon as I started plugging it in, because positive 2 plus positive 2 is not 2, which is what I had written down. It is 4. So let me fix that real quick. Sorry about that. So it's going to be x is equal to 4. Let me start back up here. And I will have 4 minus 2. And I'm going to square that. Minus 4 is equal to 0. 4 minus 2 is going to be 2 squared minus 4 is equal to 0. And then I have 2 squared, which is 4, minus 4 equals 0. Again, all I'm doing is plugging in my solutions back to the original equation so I can check to see if my answer is correct. Now my next problem, I'm going to plug in 0. So again, my original equation was x minus 2 squared minus 4 equals 0. If I plug in 0, I would have 0 minus 2 squared minus 4 equals 0. And then I would have negative 2 squared minus 4 equals 0. And then 4 minus 4 equals 0. And again, 0 is equal to 0. So therefore, my answer is correct. I'm not going to check every single one of these problems, but I just want to point out that if you do want to check your answers to see if you're doing them correctly, you can take the solution on the problem and just simply plug it into the actual equation to see if you're doing it correctly. And here I plugged in the 4, and then I also plugged in my 0. I plugged it into this equation here. And by doing the calculations, I can see that I do have the correct answer. It is a lot of work, but you'll get really quick at it after you work it for a while. Okay, I've cleared my board, and now we're going to look at number 2. It's just a little bit different than number 1. So we're going to start off by identifying our vertex. Again, our vertex is our h and our k. So here I have 2, and because it says negative 2, that means that it's positive, because that should be a minus sign there. And I have plus 9, and that should be a plus sign, so that tells me that my 9 is positive. So my vertex for this particular equation is at 2, 9. In order to solve the equation so I can find my x-intercepts, I will subtract 9 from both sides, and I'll end up with 3 times x minus 2 squared is equal to negative 9. I then divide both sides by 3. I'm trying to isolate my quadratic portion, so I divide both sides by 3, and I end up with x minus 2 squared is equal to negative 3. In order to get rid of my my squared, I'm going to take the square root of both sides. And as soon as I start to take the square root of both sides, you should recognize that you have a negative inside the radical. And you cannot have a negative inside the radical. And if you do, that tells you that this parabola will not cross the x-axis at all. And so you would have no x-intercepts. And we call that no solution anytime we have no x-intercepts. It does not mean you don't have a parabola. It just means it's not going to cross the x-axis. What I would like you to do now is I would like you to look in your notes, and if you don't have notes in front of you, you can just get out a piece of paper and go ahead and solve problem number 3. Identify its vertex of this quadratic equation, and then find the solutions. When you're done with that, go ahead and turn the video back on, and I will have worked the problem out for you, and you can check your work according to my work. You will need to pause the video after you turn it back on so that you have enough time to check your work. So I'll give you just a second to go ahead and turn the video off, and then when you turn it back on, my work will be showing. Okay, here is the work for this equation, and you should have gotten your x-intercepts as 4 and 0 and 2, 0, and your vertex should have been 3, 2. A couple things I want to point out before you pause the video and compare my work to yours if you didn't get the same answer is that when you subtract this negative 2 from both sides, or the 2 from both sides, don't be really quick to say that it's no solution until you have the quadratic portion isolated. And because if you were quick to say, oh, a negative 2 on the right side of the equal sign, I can't have that. I'm going to take the square root of it, and it's going to be a no solution. And you haven't taken the time to isolate it, you might forget that this negative sign that is next to it will cancel out any negative that's on the right side. So it's very important that you don't do that too quickly, that you make sure that the quadratic portion is actually isolated before you determine that you have no solution by having a negative number. The other thing that I want to point out is a lot of people make the mistake of thinking that a 1 under the radical means that you have an irrational solution. You're going to have a solution with a radical in it. And 1 is a perfect square. It's probably the one perfect square that everybody forgets about, because 1 times 1 is 1. So make sure anytime you see a 1 in the radical that you know you really can take the square root of 1. And then of course you would not forget your plus or minuses. That would be the next mistake that people may make, or you may have made, forgetting your plus or minuses. So if you would like, you can pause the video at this time and go ahead and check your work compared to the work that I have shown here. And then when you're ready to resume to the next problem, you can start the video again. In problem number 4, we have fractions, and a lot of times we're really quick to get a little paranoid whenever we see fractions. But you're really just going to solve this problem just like you would all of the others. So to start off with, I'm going to isolate my quadratic portion right here by adding 25/4 to both sides. 25/4. And when I do that, I'm going to have that quadratic portion by itself, x plus 1/2 squared is going to equal 25/4. Now that that is isolated, I can take the square root. I can take the square root of both sides. And when I do that, I have x plus 1/2 is equal to plus or minus. Now, as you recall from radicals, anytime I take the square root of a fraction, I'm simply going to take the square root of the top number and the square root of the bottom number. So square root of 25 is 5, and the square root of 4 is 2. So I have plus or minus 2. I'm going to rewrite the problem right here so I have some room to work. So x plus 1/2 is going to equal plus or minus 5/2. Now, I'm going to break this problem up into two individual problems so that I can take care of that plus or minus 5 halves. So I'm going to have x plus 1 half is equal to the positive 5 halves, and x plus 1 half is equal to the negative 5 halves. I'm going to subtract 1 half from both sides. And when I do that, I have x is equal to 4 halves, which is 2. And on this problem, I subtract 1 half from both sides. And I'm going to end up with x is equal to 6 halves, negative 6 halves. And that is equal to negative 3. So I have identified my x-intercepts as 2, 0, and negative 3, 0. My vertex, almost forgot to identify that by just looking at my h and my k. And again, it's minus and plus. So I know my vertex is going to be 3, positive 5. Number 6 is also a fraction problem, and I'm going to have you do this one on your own so that you can practice. And you can go ahead and pause the video after I give the directions and go ahead and do your work, and then start the video again to check your work against mine. One of the things I do want to point out is that sometimes we have irrational answers, and when we have an irrational answer, we need to be careful not to break that up into two different problems. We can write that as one. So I know that we have not yet done problem 5, so we'll go back to do problem 5, but I want to give you a chance to do problem 6 as a fraction, and then afterwards we'll go back to problem 5. So take a second, do problem 6, be careful of that radical, and then start the video again when you're ready to check your answer. Okay, this problem is a little complicated, so hopefully you can follow my work here. What I did was I added 3/4 to both sides, and that allowed me to isolate that quadratic portion. X plus 3 halves squared is equal to 3/4. And then I'm going to take the square root of both sides. Now, because 4 is a perfect square, I can take the square root of that, making that 2. And that's where I actually got this 2 from, right here. It came from this 4, the square root of 4, and that's what gave me the 2. Then I subtracted 3 halves from both sides, and when I did that, when I subtracted the 3 halves, I was able to write that just as one irrational equation. So here you'll see that as negative 3 plus or minus square root of 3 over 2. I can break them up into two separate x-intercepts as I did right here, but I really don't have to. If you were to write it as one answer, that would be okay too. Your vertex is just identifying your h and your k values, and so here's my h value, and I just lost it all. But here's my h value, and here's my k value. Let's see if I can bring that back up. Doesn't look like I can bring that back up. I've lost that those answers. But I do want, if you need to, you can rewind this video just a little bit just to get those last problems. But my h or my x of my vertex is 3 halves, and my k is going to be negative 3 halves, and then my k will be negative 3/4. Again, we have to watch those operation symbols. Let's do number 5, just in case 6 dealing with the radical was a little hard for you. I just wanted to make sure you had a taste of the fraction one before we did 5. So we're going to go back and do 6 at this time. I'm sorry, we're going to go back and do 5 at this time. We're going to start off by subtracting 5 from both sides, just like we did before. And we'll have negative that x minus 3 squared. And that's going to equal negative 5. Again, don't be really quick to think that that's going to be a no solution, that you're going to have a radical or a negative symbol in your radical, because you can't do that until you have that quadratic portion isolated. So we're going to now divide both sides by -1 in order to get rid of this negative sign. Remember, there's really a 1 there. And we have x minus 3, all of that squared, is equal to, now our 5 is positive, so we can get a solution. Our next step would be to take the square root of both sides. And when I take the square root of 5, 5 is not a perfect square, so I'm just going to get a radical answer, plus or minus square root of 5. And I'm going to have x minus 3 equals plus or minus square root of 5. I'm going to rewrite that over here so I have some more room to work. X minus 3 is equal to plus or minus square root of 5. You should have plenty of work room on your worksheet though, even though I have to use the extra space. Then I'm going to add 3 to both sides. Now when I add 3 to the radical portion, I cannot add 3 to the number inside the radical. They're like two different terms, so that doesn't work. So I'm simply just going to put the 3 in front, plus or minus the square root of 5. And of course that is what x is equal to. I do have two different x-intercepts. The first one would be 3 plus square root of 5. And of course my y is 0, so that's my ordered pair. And my other one is 3 minus the square root of 5. I'm going to put that in a radical. 0, my y is 0. And those are my two x-intercepts. My vertex, again, I just identify my h and my k. My h and my k. I do have a negative and then a plus sign, so I just write those. Those are going to be both positive numbers. So 3, 5 is my vertex for this problem. So sometimes you will have a radical answer. As a matter of fact, completing the square is just for when you have radical answers. I mean, you can use it for other problems. You can use it when they come out nice, but usually we use this method and the quadratic formula method when we have an equation that's not easily factored. If we can easily factor it using double bubble or bottoms up, we'll use those methods first. But sometimes we have to go ahead and use this method so that we can get our irrational answers. We're now going to take this one step further, and we're going to take an equation that is in standard form. We're going to convert it to vertex form, and then we're going to graph everything on a coordinate plane. So the first part of this is a review from the previous lesson, taking an equation from standard form and putting it in vertex form. Now in order to do that, the very first thing you're going to do is identify your vertex. So we're going to write our equation in vertex form. We need to identify what is the h and what is the k value. So I need to identify my a, my b, and my c of my equation when it's in standard form. I'm then going to take my b value and plug it into the formula. Now the formula is negative b over 2a. So I'm going to put that as negative 2, because negative 2 is my b, over 2 times my a, which is negative 1. Negative 2 will be a positive 2, and 2 times negative 1 is negative 2. That makes my x of my vertex negative 1. Once I know my x of my vertex, I can find my y, or I guess I can find my y by plugging that back into the equation. So I have negative 1 squared. And that is my negative x squared of my original equation. Then I have minus 2x, which is negative 1, plus 8 is equal to 0. Negative 1 squared would be positive 1, and then I'm going to take the negative of it, so it's going to be negative 1, and negative 2 times negative 1 is positive 2, so plus 2 plus 8 equals 0. 2 plus 8 is 10, minus 1 is 9. So my y is going to be 9. And I keep writing 0, but really that's my y value anytime I have a 0. So my y is 9. My x is negative 1, and my y is 9. So to write this in vertex form, I'm going to write my a value, which is a negative 1. I can just write negative though. X minus my x value, which my x value is negative 1, so I'll write plus 1 squared. And then I'll have plus my k value, or my y value, which is 9. So my k is 9, so I write plus 9, and then equals 0. Now I'm going to solve the equation for x, and I'm going to do that by isolating the binomial on the left, and then taking the square root of both sides of the equal sign. So if I have, on the right side of my equation though, if I have a negative sign, I need to remember that that will mean I have no solution. So the first thing I'm going to do is I'm going to subtract 9 from both sides. And I will have negative x plus 1, that should be squared, is equal to negative 9. I do have a negative number on the right side of my equal, but I'm not finished yet. So I need to divide both sides by a negative 1. And when I do that, I will have x plus 1 squared is equal to positive 9. Now I can take the square root of both sides, and I should have x plus 1 is equal to 3. I'm going to subtract 1. I'm sorry, that's plus or minus 3. Can't forget that. Subtract 1 from both sides. I probably should break this up into two equations so you can see it a little bit better. So let me do that. So I'm going to have x plus 1 equals positive 3, and x plus 1 equals negative 3. I subtract 1 from both sides, and I will have x is equal to 2. And on this side, I will subtract 1 from both sides, and I will have x is equal to negative 4. So my x-intercepts here are 2 and negative 4, 2, 0, and negative 4, 0. And my vertex, by looking at my equation, I have a plus 1, so that is my vertex is a negative 1 and a positive 9. Now what I'm going to do is I'm going to take this information and I'm going to graph it on a coordinate plane. So now I'm going to sketch this on the coordinate plane. I have a really big y value, so I don't know if it's going to fit exactly, so let's try it out. It's negative 1, and then 1, 2, 3, 4, 5, 6, 7, 8, and we're just going to make it go right above the graph. And then my x-intercepts will be on negative 4, so 1, 2, 3, 4, and positive 2, which will be right here. And I'm going to draw my parabola. And if you recall from the original equation, we did have a negative a value, and a negative a value will tell you that the graph has a maximum. It's actually a reflection because it's going downward. So here's a sketch of our original equation, and with a vertex of negative 1, 9, and the x-intercepts of 2 and negative 4. So in order to solve equations using the vertex form, we need to take our equation from standard form and complete the square in order to put it in vertex form. Then from there, we just identify our vertex, and then we can isolate our quadratic portion or the binomial, take the square root of both sides, and figure out those x-intercepts by solving for x. This concludes our lesson on solving equations using completing the square.